All right, we're in chapter 10-4. Let's look at problem number 1. So it says the figures in each pair are similar. What is the ratio of the perimeters and the ratio of the areas? All right, so we already learned the ratio of the perimeters equals the ratio of the sides. All right, so that's going to equal the ratio of the sides. They didn't say larger to smaller. Okay, so it doesn't really matter which way we go. So I will just do the ratio of the sides. You could do 4 divided by 6, or you could do 6 divided by 4. It doesn't matter. All right, and of course you want to reduce that fraction. These are both even numbers. So on the top, I'm going to do divided by 2. That's a 2. On the bottom, 6 divided by 2 is 3. All right, so I just did divided by 2 on the top and divided by 2 on the bottom in order to reduce that fraction. All right, so the ratio of the perimeters is 2 over 3. All right, so this 2/3, it's both the ratio of the perimeters and the ratio of the sides because they're equal. All right, so we got that out of the way. Now let's do the ratio. We said that the ratio of the areas equals the ratio of the sides squared. All right, so we're going to have to take that fraction and square it. All right, so we said the perimeter is the side, that's 2/3. But we need to square it, so we're going to square that. And when you square a fraction, you square the numerator and denominator separately. So the numerator 2 gets squared, the denominator 3 gets squared. And let's see, 2 squared is just 4, and 3 squared is just 9. All right, so the 2/3, that was the ratio for the perimeters, and the 4/9, that is the ratio for the areas. So that is it for problem number 1. Okay, please pause and try to do the same thing on problem number 2. All right, let's start with the ratio of the perimeters. We said that the ratio of the perimeters equals the ratio of the sides. So what is the ratio of the sides? We're just going to take the sides, corresponding sides, and do 12 divided by 9. All right, both of these are divisible by 3. Let's reduce the fraction. 12 divided by 3 is 4. 9 divided by 3 is 3. So that's it. And now, part 2, the ratio of the areas. We said that the ratio of the areas equals the ratio of the sides squared. All right, so right here that we did in part 1, that's the ratio of the perimeters and the ratio of the sides. Same thing. So we just want to take that and square it. All right, so if we do 4 over 3 squared, when you square a fraction, you square the numerator and denominator separately. So the numerator is 4, that gets squared. The denominator is 3, that gets squared. 4 times 4 is 16. 3 times 3 is 9. So that's it. All right, let's look at number 9. Same instructions as before. The figures in each pair are similar. Compare the first to the second. Give the ratio of the perimeters and the ratio of the areas. All right, so we said a minute ago on the last two problems, the ratio of the sides equals the ratio of the perimeters. All right, so what's the ratio of the sides? Well, you can just do 2 divided by 4. And of course, if you reduce that, they're both even. 2 divided by 2 is 1. 4 divided by 2 is 2. Simple. All right, and then the second part, ratio of the areas. We said that the ratio of the areas equals the ratio of the sides squared. All right, what's the ratio of the sides? Well, we just did it. That's 1/2. And you want to square that fraction. All right, when you square a fraction, do the top and bottom separate. So we're going to do the numerator squared, that's 1 squared. The denominator squared, that's 2 squared. 1 times 1 is 1. 2 times 2 is 4. Done. This is the perimeters. This is the areas. All right, please pause and try number 11. All right, let's see number 11. We said that the ratio of the perimeters equals the ratio of the sides. All right, what's the ratio of the sides? Well, that's just 14 divided by 21, right? 14 divided by 21. Can we reduce that? Sure, they're both divisible by 7. 14 divided by 7 is 2. 21 divided by 7 is 3. And that's it. Simple. Now, we said the ratio of the areas equals the ratio of the sides squared. All right, so that's going to be 2/3 squared. Which means you square the numerator, 2 squared. And you square the denominator, 3 squared. 2 times 2 is 4. 3 times 3 is 9. Done. All right, number 13, the figures in each pair are similar. The area of one is given. Find the area of the other to the nearest whole number. Okay, that means round off, no decimal places. So let's look at 13. So they said they want us to find the area of the other figure. They gave us the area of the smaller, so we need to find the area of the larger. All right, so we said before, let me see how much room I have here. We said before that the ratio of the areas equals the ratio of the sides squared. Okay, we can see the ratio of the sides right here. That's going to be 3 divided by 6 squared. Now, before you square it, you want to reduce that, okay? It makes it easier. So let's see. 3 divided by 6 is what? Well, they're both divisible by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. Okay? And let's see. If you square 1/2, let me write this over here because I'm making a mess here. All right, 3/6 is the same as 1/2. And it's still squared, okay? Now, you square a fraction. Numerator squared is 1 squared. Denominator squared is 2 squared. 1 times 1 is 1. 2 times 2 is 4. All right, so that is the ratio of the areas. All right, so let's finish this problem now. We have the ratio of the areas. One over 4. And over here is going to be the actual areas. In fact, On the top, in the numerator, that is the smaller parallelogram, and the larger parallelogram is clearly the one on the bottom. Okay, so this fraction is the ratio of the areas, and the next fraction, that is going to be the actual area. All right, so they gave us the area of the smaller is 6. All right, so the actual area of the smaller is 6, and the area of the larger we don't know. All right, so now we're in business. All you have to do at this point is cross multiply. 1 times x, and that equals 4 times 6. So 1 times x is just x. 4 times 6 is 24. The units were in inches squared. So that is your final answer. All right, so basically, we found the ratio of the sides, we reduced it and squared it, and then we used that new ratio and set it equal to what we were given. All right, please pause and try number 15. Try to do the same thing. All right, they give us the area of the larger. So, of course, we want to find the area of the smaller. So, we said a minute ago, the ratio of the areas equals the ratio of the sides squared. All right, and for the ratio of the sides, what are we going to do here? Well, we're just going to do 16 divided by 12. And that gets squared. Once again, before you square it, you want to reduce. These are both divisible by 4. 16 divided by 4 is 4. 12 divided by 4 is 3. Okay, when you square a fraction, you square the top and bottom separately. 4 times 4 is 16. 3 times 3 is 9. So that's not the final answer. That's just the ratio of the areas. All right, and we're going to use that with the 105. All right, so first fraction is going to be the ratio of the areas, and the second fraction, that's going to be the actual area. All right, so for the ratio of the areas, we got 16 over 9. So clearly we're doing the larger one in the numerator and the smaller one in the denominator. Okay, what's the actual area? Well, they gave us the larger one. The area of the larger is 105. So the larger one is in the numerator. That's 105. And the actual area of the smaller one, that's what we're trying to find. So that's just x. All right, cross multiply. 16 times x equals 9 times 105. All right, the opposite of times 16 is divided by 16. Cancels here. And I'll do this on the calculator. To the nearest whole number, I think they said, I get 59. Okay, I got a decimal, but it kept going, so I rounded off. The units were in feet squared. So this is going to be in feet squared. All right, so that's basically it for number 15. All right, last section. They want us to find the scale factor and the ratio of the perimeters for each pair of similar figures. All right, we know that the scale factor is just the ratio of the sides. Okay, and we know that the ratio of the sides equals the ratio of the perimeters. So these are really one and the same. There's really only one answer per problem. Okay, it looks like two, but there's only one. All right, let's start with number 20. They give us the ratio of the areas, and we want to find either one, the scale factor or the perimeters. Ratio of the perimeters, same thing, same thing. All right. So we said before that the ratio of the sides is going to equal the square root of the ratio of the areas. Okay, because now we're going the other way. Before we had to square it to get the ratio of the areas. Now we have to take the square root to get to the ratio of the sides. All right, so that's going to be the square root of the ratio of the areas. What's the ratio of the areas? It's 75 and 12. So just do 75 over 12. All right, always try to reduce it first. So we have the square root, 75. These are both divisible by 3. 75 divided by 3 is 25. And 12 divided by 3 is 4. And now we're in business. Okay, when you take the square root of a fraction, you do the top and bottom separately. So it's going to be the square root of 25 divided by the square root of 4. Square root of 25 is 5. Square root of 4 is just 2. So that is your final answer for number 20. All right, please pause and try number 22. So we said the ratio of the sides is the ratio of the square root of the ratio of the areas. Okay, they gave us the ratio of the areas right here. So that's going to be 18 divided by 32. And we're taking the square root of that whole thing. Let's reduce first before we take the square root. These are both even. 18 divided by 2 is 9. 32 divided by 2 is 16. All right, and now we're in business. Do the top and bottom separately when you take the square root of a fraction. The square root of 9 is just 3, and the square root of 16 is just 4. Final answer.